Hi team, Wednesday the 11th of May. I'm still out, as you may have noticed. I apologise. So this is the second lesson I wanted you just to watch the video on. Take notes. You probably are going to want to watch the video just because the notes are kind of sparse and I'm going to extract a lot of the ideas. Yesterday on Tuesday, you should have watched a video on the two laws of thermodynamics, and on Thursday and Friday, you're just going to be working on your study guides. Remember, study guides, 10% extra credit on your final exam, seniors. You need to be working on the study guides too. You don't have to worry too much about this video. I'm just working your study guides so you can hand me your study guide on the day of your final exam. Anyhow, we are today going to be talking about water properties and why water is good for the planet, why it enables life to exist on the planet. And there's a number of features about water that make it kind of unique, but I just want to explore some of the ideas that really help life exist on the planet. If water didn't act this way, it just wouldn't happen. Life wouldn't exist, right? So yeah, let's get going. First big idea is ice density. So water does a very odd thing. Normally when you get cold, everything contracts, right? Same with liquids. Liquids, they get smaller and smaller volume when they contract. And then normally when a liquid turns into a solid, it gets really dense. Water is totally unique. It contracts, 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 but then as you get to the freezing point and water itself freezes, it expands. It expands due to the hydrogen bonds, and it forms those little Mickey Mouse, if you think of the H2O being the little Mickey Mouse ear where the face is the oxygen and the two little ears of the H, they kind of form this nice little grid pattern that actually makes it expand. And the result of that is that ice floats. Any other liquid, the solid form of that's going to sink to the bottom, but the solid form of water floats. Totally unique. Very few other substances that I know of do that. But this is essential for life on Earth. Why is that? Well, a couple of reasons actually, and I guess we'll get to them in the next slides. The first reason is that ice has a very low thermal conductivity coefficient. What does that mean? If you remember, metals have high thermal conductivity coefficients. Metals will transfer heat very, very quickly. If you put a metal spoon in a pot of boiling water, the dry end of the spoon will get very hot very quickly. Wood has a very low thermal conductivity coefficient, so you put a wood spoon in the boiling pot of water, you hold it down, the end of the wood spoon's not going to get hot. Heat doesn't transfer through it because it has a low thermal conductivity coefficient. The reality is ice is the same. Ice has a low thermal conductivity coefficient, which makes it a good insulator. And if you think of every lake north of that freezing line, I don't know where that is, probably like North Carolina, Virginia, or maybe probably even further than that, where lakes and ponds freeze in the winter. Well, fortunately, the ice floats to the top. Right? Which means there's water underneath the ice, as you well know. Well, this is a beautiful thing because even though the air is insanely cold, the ice actually acts as an insulator and keeps the water cold but warm. It doesn't let the water freeze, right? So all that aquatic life, fish and everything else like that, the plants in the ponds, they can still live underneath the ice, and they do. They do. Now imagine just for a second what would happen if ice sunk. If ice sunk, then the bottom of the lake is going to be full of ice, and as it goes on, it's going to fill up, fill up, fill up. It's going to be one solid mass of ice, and all the fishes are frozen and dead, which is a shame. So yeah, ice is a very good insulator. You think of your igloo. Honestly, it seems kind of daft making a house out of ice, but ice is a very good insulator. So it actually keeps you warm in there, or keeps the cold out. Whatever warmth you bring to the house, it traps it inside the igloo. Yeah, the inside of the igloo is going to melt, but you know what? You're not freezing to death, so we'll take it. Second reason is heat capacity. As we have discussed before in my class, water has a very high heat capacity, which means it is very hard to heat water up. It takes a lot of energy to heat water up, right? Now, I don't know if you noticed, look at this. This is planet Earth, as you may or may not know. Planet Earth, as it turns out, is about 2/3 water, give or take. 2/3 of our planet is ocean. And this is a wonderful, beautiful, amazing thing, because what that means is all of that sunlight, all of that heat energy that hits our planet, 2/3 of that energy goes to heating up water, and that slowly raises the temperature. Now imagine, if you will, 12 hours later, the planet has spun around, America's in nighttime. Well, yeah, it gets colder at nighttime, we all know that. But imagine if there was no water, right? At nighttime, all the water, all the oceans are slowly releasing that heat back into the atmosphere, right? And then in the daytime, it's quickly absorbing the heat energy, getting warmer, and then slowly releasing it at nighttime. If there were no oceans, then there would be radical temperature fluctuations. The moon, Mars are examples of this. I don't know the exact numbers. I looked it up once, and it was somewhere like, on the moon, it can get to like 80 degrees Fahrenheit. I say this in good faith, I'm probably wrong. But then at nighttime, it gets down to like -100, -150, maybe even -200. Huge temperature fluctuations. Even the Sahara Desert, it can be 110 during the daytime, where it's miles and miles and miles, thousands of miles from the ocean. And then at nighttime, it'll go down to 40. Right? Huge temperature fluctuations. But because of our planet as a whole is mostly water, we do not get these wild fluctuations. We are pretty temperate. All right, and the third, maybe fourth example of why water is awesome is something called the albedo effect. Now, I don't know if you noticed, because, we're teaching in Florida here, but if you've ever seen snow or ice, it tends to be white. And this is wonderful. Truly, truly wonderful. Why is it so wonderful? Well, the reason is we've talked about light and color and how, a green t-shirt absorbs all the colors apart from green, reflects it back. A red t-shirt absorbs all the colors apart from red, reflects red back. White reflects all of those colors back. Black, of course, absorbs all the colors, it gets hotter quicker. White reflects all those colors back. Snow and ice is white. The majority, 90% of the solar radiation that hits snow and ice is reflected back out into space. 10% is absorbed into it to heat it up. But if you take that snow and ice cover away, now we have a darker surface. Now we got 94% of that heat, solar radiation heat, is being absorbed, 6% is being reflected back. So you're going to warm up more. Now, this is scary, by the way. This is a wonderful thing. It means all these ice caps on the North and South Pole, Greenland, northern Canada, Siberia, all these permafrost places, they're keeping our planet nice and cold. But imagine, if you will, we get to a point where the snow and the ice caps start to melt. Right when you have the ice here, most of that radiation is being reflected out. It's keeping the planet nice and cool. But if it melts, then the white goes away and it releases dark Earth underneath, right? It could either be bare rock, or it could be soil, or it could be anything else. Either way, way more of that radiation is going to be absorbed. When more of that radiation is absorbed, what happens? It warms up that area. It's going to melt more of this snow, more of this ice, revealing more rock. More radiation is absorbed into the rock, meaning it gets warmer, meaning more ice is melted, and you get what's called a positive feedback loop, right? Before you know it, you've lost all your snow, all your ice. This is how glaciers are retreating. This is how the ice caps are going away. And this is a big, big, big problem. Again, it's a positive feedback loop. The more ice melts, the more it reveals rock underneath, the more that rock is going to absorb the heat, melting more ice. Once all that ice is gone, we are somewhat out of luck. SOL, somewhat out of luck. So here's your exit slip question, and I would like you to think about this, which is Greenland, right? You got Canada here, this is England right there, Russia, all the way. Greenland has a huge ice cap on it, but it's melting. Scientists are very worried about it. It's melting. Why is it going to be pretty bad for the planet if all of this ice melts on Greenland, right? It's a rocky thing. The ice has been there for millennia, right? It's not like there's grass underneath that just needs to thaw out. It's been there for thousands of years. So why is it a big wahala, big problem if all of this ice melts? That's your exit slip question, and I'm going to call it. I will see you guys on Monday, Thursday, Friday, working in study guides. Make sure you get this exit slip in. It is a grade. All right, have a good one, chaps. Wide out.